Hi everybody, here is your last lesson for personal finance. So this is your last bit of new material and your third and final formula you're going to see. And this has to do with calculating the present value. Our learning goals, we are going to review compound interest from the previous lesson and calculate present value. And both this lesson plus the last lesson, they only deal with compound interest, not with simple interest. But instead of now finding the future value, we're going to find the present value, which, as you're going to see, is actually a little bit more useful to you, especially when you get older. So our first example, calculate the amount of an investment that was $5,000 invested at 4% compounded biweekly for 2 years. So you're looking for compound or simple, and we see compound. So we know we're using the formula for compound interest. Right after it, we see biweekly, which is your C value. So we know we're doing this. These are our variables. We want to know the amount. So the future value, the P, which is the principal, which is just another with the starting amount, which is another way of saying the present value, how much do you have presently, but we'll get there. So think of, again, P is our principal value or starting amount, $5,000. My interest rate, 4%. Don't forget, don't just write 4. Make sure you divide by 100 to get the decimal. C, your compounding period, biweekly. Do you remember what number we associate with biweekly? Hopefully you're thinking 26, right? Every other week. T for time, 2 years. Go to our formula. A equals, I'm not going to write out the formula from scratch. If you need to, just like last lesson, you can, or just refer to the formula from last lesson, but A equals P, 5,000, bracket 1 plus 0.04 divided by 26, and our exponent, C times T, 26 times 2. Don't forget to do your exponent first. 26 times 2, 52, and then enter it just like you see it. 5,000 bracket 1 plus 0.04 divided by 26, close bracket, exponent 52. Since it's money, remember, even if I don't tell you, 2 decimal places. Hopefully you get $5,416.10. On a word problem, therefore, blah, blah, blah. And don't forget, like last lesson, I could ask you how much of that was interest. Subtract your initial amount that you put up, your own money, $5,000. So in this instance, you earned $416.10 in interest. Our next example, how much interest is earned if $2,000 is invested at 2.25% compounded. So compounded monthly, that's your C value, for 2.5 years. We see compounded, we know these are our variables. Now this question actually has 2 steps, even though I didn't ask it in a part A, part B type question. It wants to know how much interest is earned. So that's kind of like what I just told you to keep in your back pocket from the last example. So our game plan here, figure out how much money we have altogether at the end of the day, our future value, and then subtract our own money. So the money that we put up, which was $2,000 in this case. So we kind of have to find the future value first. My starting amount, $2,000. My interest rate, don't forget to divide that by 100. So you should get 0.0225. My C value, monthly. Monthly, what number is that? How many months are there in a year? Hopefully you're shouting out 12 times 2.5. Plug that into our formula. A equals 2000, 1 plus 0.0225 divided by 12. And then our exponent, C times T, 12 times 2.5. Do your exponent calculation first. 12 times 2.5 is 30. And then enter that just like you see it. So you can pause it if you want. Come back, see if you get the same number as I do using your calculator. $2,115.61. Now remember, the question is asking us how much interest we earned. So that's how much we walked away with in 2.5 years. How much of that money, though, did we put up ourselves? Well, we invested $2,000 of our own money. So if we want to calculate how much interest we earned, just subtract how much of our own money we put in. Which in this case, take away your $2,000, you're left with $115.61. And that is our interest earned. And of course, our therefore statement. So those are two good review questions to see how much you got from the future value, compound interest lesson from before. Our next example is going to act as a review, but also a segue into present value. So for our third example, let's say you're starting college, university in roughly 2 years. You'd like to have $5,000 when you start. You have $3,000 now. And you found a bank that's going to pay you 2.75% compounded semi-annually. Will you have enough money? So, again, we see compounding semi-annually. That's got to send our mind here. We want to know if we're going to have enough. And remember, this right here is our goal. So we want to see if we'll have 5,000. So let's see what our future value is. We have, not 2,000, we have 3,000. My interest rate, 0.0275. Semi-annually, so every half year. Our C value is 2. And your time, roughly 2 years. So A equals 3,000, 1 plus 0.0275 divided by 2, exponent 2 times 2. Doing your exponent first, 2 times 2 is 4. Enter that in your calculator just like you see it. And you're going to see we actually come up pretty short. So we end up with, shouldn't be 1,000, should be 3,000. 3,831. Backtrack on that. I don't think that's right. Let me double check that calculation again. And if you got something different, then that's good. I'm just going to double check that. So hopefully you get, I think this is better, $3,168.43. So in those 2 years, you made $168.43 for free. However, Did we reach our goal? Remember, our goal was $5,000. We didn't. And if I was to subtract my goal minus $5,000, you're going to get a negative. And you're going to get negative $1,831.57. And that negative tells you you're short. So we are short of our $5,000 goal. What if you wanted to know though, like you wanted to have a goal, like you had a goal of $5,000. We calculated that we came up short, but isn't it possible, like maybe a more effective calculation for us to think about, well, what do I need right now to get $5,000? Then I don't have to do trial and error. Because we could do like, well, what if I had 3,500? What if I had 4,000? What if I had 4,500? What if I had 4,600? Like you would just be sitting there trial and error. So this is the more useful side of compound interest, is you setting goals. So this is what we're going to get into for the rest of this lesson. I have a goal. It's $5,000. How much do I need to save up to be able to have $5,000 in the future? Maybe you want to go on vacation, when we can go on vacation again, and you know how much the resort's going to cost. How much do you need to invest today so that you can go on vacation, let's say in 2 summers? Maybe you want to save up and buy a car. How much money do you need to invest today to buy a car, to buy a house, or anything else? This is the more useful calculation for you, telling you what you need to have today to reach your goal in the future. So what I just explained there was the whole idea of present value, which is your starting amount, your principal. So this is the value of your investment, or on the bad side of things, a loan, on the date before the end of the term, meaning how much do I need now, or how much do I need today? The first thing I'm going to do is give you the formula, and it's almost identical, except for a couple things. So 2 things to notice. The P and the A switch spots. So instead of looking for the final amount, we're looking for the present value. And your exponent is negative. Other than that, everything is exactly the same, and all those letters mean the exact same thing. Now, how are you going to tell the difference? Because if you remember from the opening, I told you all of these questions are going to do with compound interest. So how do you tell if this is like a future value or a present value? Well, for present value, you're looking for some keywords, and it might not always be these 2, but 2 of the more prominent words you're going to see is how much do you need now, or how much do you need today? So you're going to be looking for those 2 words versus the kind of review examples we did to start plus the last lesson. It's asking you what is the final amount, or how much are you going to have in the future. So that's how you're going to tell it to use this formula or the formula before. So getting back to our post-secondary question, Kyle wants to invest enough money today. So already you see the word today. You got to be thinking present value. To have $5,500 for tuition when he goes to college in 1.5 years. He's going to invest his money at 6% per year, compounded monthly. How much does he need to invest today? So I've even put it in this question twice for you to drive the point home. So we're still using these letters. Why are we using these letters? Because compound. So we're not using the simple interest, because you'll see simple. And then the word following compound is your C value. But we'll do these first. So we're not looking for the final amount anymore. We know what the final amount is. The final amount is our goal. In 1.5 years, Kyle wants to have 5,500 in the future. 1.5 years in the future, he wants to have 5,500. The present value, the value he needs today, that's what he's looking for. Our R value, don't forget, don't just put 6 in, convert it to a decimal first. So 0.06. Your C value, what is the compounding period? Well, it comes after the word compound, monthly. Monthly is 12 months in a year. Time in years, 1.5. Since we are looking for the present value, that question mark is beside the p-value. We're using this formula, which I'll just rewrite it again for you. Now it's just plug and play. 5,500, 1 plus 0.06 divided by 12, and then 12 times 1.5. Negative 12 times 1.5. Do your exponent calculation first. Negative 12 times 1.5. Negative 18. And then enter that just like you see it. Just like we have a kind of a built-in self-check for future value, in that if you're investing money or you have a loan, it's going to accrue interest. The final amount should always be bigger than what you invested. Otherwise, it wasn't a very good investment. On the flip side of things, when you're looking for the present value, it should always be less. So this number we get should be less than 5,500. Otherwise, our investment didn't make us any money. Our investment lost us money. And we're not going to do anything complicated like that. So you enter that just like you see it with the negative exponent, and you should get $5,027.75. It's definitely less. It's not that much less, but he only invested his money for 1.5 years, and he still walked away with $472.25 for free. So that's how much he would need today. So Kyle would need that much money today to be able to have 5,500 for his tuition in 1.5 years. That more or less would be your therefore statement. Our last example for this lesson, we're talking about a loan. So JJ has a loan for $5,000. It's due in 4 years. He wants to pay off his loan early. The creditor, which is the person who loaned him the money, is willing to discount the loan at an interest rate of 8% per year, compounded semi-annually. How much would the creditor be willing to accept today? So we see today, we see compound, and semi-annually is our C value. So we know we're using these. Now this often happens. People take out loans and they're going to be due in a certain amount of time in the future. And then maybe, JJ gets a good job, or maybe he comes into an inheritance, but he's come into some money early and he wants to pay it off. So he wants to pay it off early so that way he doesn't have to pay off the full $5,000. And then the creditor sometimes is willing to discount the loan because they would like to get paid off sooner. So maybe JJ's a credit risk, maybe he might not pay his bills, maybe he leaves the country, who knows? So the creditor is willing to accept a discount on the loan. How much would they be willing to accept today? So we see today that's present value. His loan is going to come due at $5,000 in the future. My interest rate, 0.08. My compounding period, semi-annually, which is 2, and the time, it's due in 4 years, so 4. Using our present value, P equals the A value, which is 5,000, 1 plus 0.08 divided by 2 to the negative 2 times 4. Do your exponent first, which gives you negative 8. Then enter that into your calculator just like you see it. You should get $3,653.45. So this works out better for JJ. He saves some money on his loan. He doesn't have to end up paying the full $5,000. He ends up having to pay $3,600. And the creditor, the person who loaned the money, doesn't have to wait 4 years to collect $5,000, or maybe JJ doesn't pay his bills, who knows. Instead, they're willing to accept $3,600 today instead. So that's it. If you have any questions about present value or anything else from the unit, make sure you let me know. There's lots of time to work on things for this unit. So again, you have this is the final lesson, so this introduces you to the third and final formula. There's a couple of review lessons coming up. Then you're going to have your test, and you also have your assignment done by last name that's absolutely due by 3 o'clock. And then, again, since you have lots of time, if you would like to start preparing for your CCA, I would highly recommend that you do so. And I mentioned in a previous lesson how to prepare for your CCA. Make sure you do your reviews in your workbook, your exam review in your workbook. There's some exam reviews in the content section, etc., etc. Make sure you're ready for next Monday and next Tuesday after you complete all of your finance work. So that's it. Keep an eye out for the 2 review video lessons before your final test.